has started? Okay, one section 10A has started. There are two different schools? Same school, okay. So second class has not done. Fine, then I'll start with the concepts, core concepts. What is chemical equation and how do we balance them and how do we make equations and formulas? I hope you have done the formula making part in 9th class.
Yes.
Make a formula. Do you remember the charges of on atoms? What charges exist on which atom? You know that or not? Do you remember atomic numbers? Yes, from 1 to 10 or 1 to 20.
30.
Okay. And you know their configurations as well?
Yes.
The charges also? Yes or no? Yes. Okay. Let me see. So our chapter is chemical reactions and equations. Chemical reactions and equations. See, what is there in chemical reaction? Chemical reaction, we call it a chemical reaction when some reactants react to form some products and something new is formed. There are many kinds of reactions, but if the reactants combine with each other chemically, they make a bond and the old things, whatever we call them reactants, if they form a new thing, that are called products. Okay? They break the bonds and make new bonds and form new things which are called products. See, we have reactants which we write in left hand side and they react with each other. They may be one or more than one also, but generally the reaction carries two reactants or more than two also, and they combine to form products. For example, if you have, this is on the right hand side. For example, if you have this H2, H2 and I2, they react to form HI. Right? This is a chemical reaction. These two are reactants and they react to form product. So reactants are written on left hand side and products are written on right hand side. And here we have an arrow and we also mention the state of the reactants. It may be solid, liquid, gas, aqueous, molten, whatever. These are the states of reactants or products. We have to mention that. But one thing is missing in this reaction. Can you tell me what is missing? This reaction is not balanced, right? I've made the reactants, I've made the products, but you must have learned the law of conservation. Do you know what is law of conservation?
Yes.
What is law of conservation? Will tell me.
That mass can neither be created nor be destroyed in a chemical reaction.
Not necessarily in a chemical reaction, wherever in whole universe. It can be applied everywhere. That is why it is universal law. Okay? So here I've taken H2, I2, but I'm getting just one H and one I. That means I've destroyed it. I cannot. Law of conservation means whatever you have taken, you'll get the same. Balancing of equation is necessary because you cannot create anything, you cannot destroy anything. If I do not balance it, that means I've lost one hydrogen and one iodine, which is not possible. So to balance it, I have to equate the number of atoms on both the sides. I have to take equal number of atoms on both the sides. That is balancing, and that is necessary because everything follows law of conservation. You cannot create anything. You cannot destroy anything. It means whatever you have taken, you get the same thing, right? So this is a chemical reaction. Reactants, products, This arrow represents that these things are giving you this thing. What is happening here? You have H2. Hydrogen exists as diatomic molecule. Diatomic, दो atoms. Okay? They are joined with each other with a bond. This is H2. It exists as gas. H2, O2, N2, Cl2. All these exist as gases. Right? So I've written that this is in the gaseous state. This exists like this. This is a reactant. Second thing I've taken is I2. I2 exists as I, single bond I. So when they react, they dissociate this bond. This bond breaks and they form bond with each other. That is, they form HI, but two molecules of HI. Right? Second thing, can you tell me the difference between this two and this two? What is the difference between these two? Two. Do you know what is the difference? Yes or no? Tell me. No? Yes or no तो बोल सकते हो. Okay, I'll tell you. I'm asking you, what is the difference between this and this? This is called atomicity. Atomicity of an element. Right? This is also atomicity of an element. How many atoms are combined with each other? That is called atomicity of an element. But this is coefficient. In language of chemistry, it is mole. Like 2 moles of HI. Right? For balancing, you cannot change this. Right? For balancing equations, you cannot change this. Why so? Because this is their natural occurrence. How do they occur in nature? You cannot change that. If hydrogen occurs as H2, that is its existence. It exists as H2 only. Iodine exists as I2 only. You must have heard of ozone that exists as O3. Phosphorus exists as P4. Sulfur exists as S8. You cannot change these things. They exist like that. You have to learn this. Okay? Now, this is for balancing. You can only change the number which is placed before these molecules or atoms. You can just change this number during balancing. You cannot change this number, which is atomicity. You can just add or multiply this thing with the coefficients, but no, you cannot change the atomicity of any element, right? So those who are starting the chapter, I'll give just, I was told to, make you learn balancing of equations, but one of your class has not done anything. So I'll give a brief introduction of the chapter and I'll proceed with the balancing then. So write down chemical reaction. Right, whenever a chemical change occurs, comma, a chemical reaction takes place. A chemical reaction takes place. In chemical reaction, one or more substances are transformed into new substances. Into new substances. Like here, two things are transforming into one thing. So one or more substances that is transforming into new substance. This H2 and I2, this is giving you HI. Then write about reactants. Reactants. Reactants are substances that undergo chemical change. Reactants are substances that undergo chemical change. Like I told you, this H2 and I2, the bonds are dissociating, they are breaking, and then new bonds are being formed, and you get products. So, right, what are products? Products are new substances that are formed during the reaction. And how do you know that this reaction has taken place? Because every time you cannot see that change, but sometimes heat is released, sometimes you see the change in color, sometimes heat is absorbed, you feel that the products are made as the solution becomes cold, right? These are the indications when a chemical reaction occurs. So you can write that observations made during chemical reaction. What do you observe? How do you say that chemical reaction has taken place? So observations made during chemical reaction. So what are the observations? First is change in state. Change in state. This is not always like that always there will be a change in state. No, but there could be any of the factors. So change in state is one of the factors. If a solid is getting converted to liquid, there might be a chemical reaction. This is one of the indication, right? So first is change in state. Write down second observation. Second point, change in color. You may observe that reactants and products are different in color. So if there is a change in color during the reaction, that shows you that chemical reaction has taken place. Third observation is point 3, write down, evolution of gas. If a gas is released, this indicates that chemical reaction has taken place. Next is change in temperature. If you observe any change in temperature, like it could be endothermic or exothermic reaction. Exothermic reaction means that there is a release of heat during the reaction, that you'll feel it that the products are hotter. And if there is endothermic reaction, that means reactants has absorbed the energy or absorbed heat and the products become cooler than the earlier ones. And last factor is formation of a precipitate. Anji? What did you say?
Nothing.
Okay. So last factor is formation of a precipitate. Precipitate means solid residue. So all these are observations which indicate the formation of products which indicates that there is a chemical reaction going on. So I've made you write 5 factors. First one was change in state. Those who have missed, please write it. First one is change in state. Second one is change in color. Third one is evolution of a gas. Fourth one is change in temperature. And fifth one is formation of precipitate. These are 5 things that indicate that there is a chemical reaction which is going on. Right? Now we will do chemical equation. Chemical equation. Write down. Chemical equation can be written using chemical formula, or a word equation, Now, what does these mean? Chemical formula and word equation. Suppose I'm writing this HCl plus NaOH gives you NaCl plus H2O. This is chemical formula of HCl is called hydrogen chloride or hydrochloric acid. NaOH is called sodium hydroxide. NaCl is sodium chloride. And H2O is called, right? So this is chemical formula, or plural mein it is chemical formulae, and this is the word equation. In words I have written what are the reactants and what are the products which I'm getting, and they are separated with this positive sign. That means I'm having 2 reactants and I'm getting 2 products, and they are separated with this arrow. This means gives. This reactant gives these products. So this is a chemical equation, and you have to balance it. But here, can you check, is it balanced or not? How do you balance the equation? You need to check how many atoms of reactants and products are there in the reactant side and product side. Like you have this NaOH plus HCl, and this is giving you NaCl plus water. This was our equation. So what atoms are we having? We are having sodium, oxygen, hydrogen, and chlorine on LHS side, and in right hand side I have sodium, I have oxygen, I have hydrogen, and I have chlorine. First of all, check. We'll proceed with sodium. You have 1 sodium here, you have 1 sodium here. So they are equal. If we check for oxygen, you have 1 oxygen here, you have 1 oxygen here. Okay, fine. But if you check hydrogen, you have 2 hydrogen atoms here and you have 2 hydrogen atoms here. This is also good. And you have 1 chlorine here and 1 chlorine here. So this is also right. So is this a balanced equation? Do we have same number of atoms on left hand side and right hand side? Yes. So this is a balanced chemical equation. Other class has missed it. So I'll repeat this thing. They lost the connection on this. Okay, he lost the connection. I was telling that this equation is, we were checking whether this is balanced or not. So we wrote the number of atoms on left hand side and right hand side, and we checked are they equal or not. So we checked that we have just one sodium on both the sides. We have one oxygen atom on both the sides. We have two hydrogen atoms on left hand side, one in NaOH, one in HCl, and two hydrogen atoms on right hand side. So they are also equal, and one chlorine atom on LHS and one on RHS. So this is also equal. So this is a balanced chemical equation because number of atoms in left hand side is equal to number of atoms in right hand side. So we'll practice the number of equations like this to check whether the number of atoms on LHS or RHS is same or not, whether they are following the law of conservation or not.
Can you explain again?
Okay, so we had this equation, I'll write it again. We had this equation NaOH plus HCl, and this was giving us NaCl and H2O. So we were checking whether this equation is balanced or not. So for checking that, we need to see whether the number of atoms on LHS or RHS, left hand side and right hand side, or reactant side and product side, are they equal or not? So let me see what type of atoms do I have on reactant side, left hand side or reactant side, and what atoms do I have on product side. So one thing, whatever you're having, whatever kind of atom you're having on reactant side, definitely you'll have that on product side. But thing is, for balancing, there will be change in number only, right? So I have sodium here, I have oxygen here, I have hydrogen here. This is also hydrogen, which I've already written. So it will come in this only. And then I have chlorine here, right? Similarly, here also, I do have sodium, I do have oxygen, I do have hydrogen, and I do have chlorine. Now, how many atoms of sodium on reactant side? Just one. How many atoms of sodium on product side? One. That means I have equal number of atoms of sodium on both the sides, which is my purpose. I need to balance this. I need to have same number of atoms on left hand side and right hand side. Coming to next element, I have one oxygen here. I write it one. How many oxygen atoms do I have on the product side?
One.
One. So this is also balanced. Coming to hydrogen, I have one hydrogen here and one hydrogen here. Total. And how many hydrogen atoms do I have on right hand side? Two. So this is also balanced. Coming to chlorine, I have just one chlorine atom on reactant side. How many chlorine atoms are present on
One.
one? So is this a balanced chemical equation?
Yes.
Okay. I'll give you another equation. We'll do it in the same way. One side reactants will be written, another side products will be written, and we'll balance it. We'll see whether it is balanced or not. We'll see which atom is not balanced. And then I'll tell you some other things, additional things also. Right? How to see that. What is the significance of this bracket, this number? How do we calculate the number of atoms in equations like this? So I have reactants this side and I have products this side. Right? And I have hydrogen, then I have nitrogen, then I have oxygen, I have calcium, then I have oxygen, which I have already written, and then I have hydrogen, which I have already written. Right? Same atoms I'll be writing here, hydrogen, nitrogen, oxygen, and calcium. Now I'll be writing the number of atoms which are present on left hand side and right hand side. Can you tell me how many hydrogen atoms are present on reactant side?
Three.
One here, and because this bracket carries 2 here, that means I have to multiply this atom with 2.
Yes.
There are 2 hydrogens this side. So total ho gaya 3. And how many atoms of hydrogen here? 2. We have to balance this, but wait. We have how many nitrogen atoms here?
One.
How many nitrogen atoms here?
Two.
So we have to multiply this with 2 because this is placed in a bracket. So this becomes 2. Oxygen. How many oxygens here?
5.
3 oxygens here and
2.
right. So we have 5 oxygen atoms here. And how many oxygen atoms here?
7.
6 here and 1 here. 7. Right? And how many calcium here?
1.
Right? First of all, you have to calculate the number like this. This should not be wrong. You should know what is the significance of these brackets, how they are counted. Right? Then comes, which element will you choose? Like, this is easiest one. This is just calcium is 1 here, 1 here. Then which element would you choose to balance? Like you have oxygen. Which elements? Choose one element which you would like to balance. Oxygen or
Oxygen.
oxygen. What would you like to do for balancing oxygen? You have 3 oxygen atoms here. If you put 2 here, how many oxygen atoms do you get in total? 3 to just 6, then 7, 8. So you have 8, right? Can you make the number of oxygen atoms 8 there also? What you have to do to make the number of oxygen atoms 8 in this side? You have 6 oxygens here and 1 oxygen here. So if you multiply this with 2, how many oxygen atoms will you get in total?
8.
So this will balance our oxygen atoms. But Acha, tell me, why did I put this 2 here? Why didn't I make it O2?
Because we can't change atomicity.
We cannot change the atomicity, whatever the existence of that. Water exists as H2 only. If I make it H2O2, this becomes hydrogen peroxide and another compound. We cannot change the compound. We just need to balance it, right? So for balancing, you can only multiply these compounds by placing the different coefficients, right? Here, before the compound, you have to place the coefficients. So now we have 8 oxygen atoms here and 8 oxygen atoms here. But this has changed some other things also because this oxygen is not alone. This coefficient has changed things for other elements also, right? What has it changed? How many hydrogens do we have here now?
4.
2 here, 2 there. We have now 4 hydrogen atoms. And how many hydrogens atom there?
4.
Over here. That means our hydrogen is balanced. Our oxygen is balanced. Coming to nitrogen. How many nitrogen atoms here?
2.
2 nitrogens here. And how many nitrogen atoms there?
2.
This is also balanced. What about calcium?
Already balanced.
Already balanced. Got it? How do you balance it? This is kind of hit and trial method. You have to choose one element and try with that. There is no fixed rule what you need to follow, right? You have to choose something and try with that, and then you need to look what changes has this coefficient has made to other elements. Then you cross check and you balance the things, right? So balanced equation is 2HNO3. I'll erase this. 2HNO3, then calcium hydroxide, then CaNO3 twice plus 2H2O. Write it down, beta.
Yes.
Let's do one more reaction, then I'll make you write some important points about the balancing so that you could understand what are those points saying, right? So I'll tell you another equation, which is N8OH. Please participate actively in balancing. That then only you will learn how to balance thing. And this is a short question. You'll definitely get a question on balancing, and you'll face problems after that. So listen carefully, participate in balancing so that you learn it. Okay. Tell me, what atom should I write first? Go in sequence.
Yeah.
Which?
Na.
Right. Next element?
Oxygen. Hydrogen. Sulfur. Oxygen done.
Right?
Yes.
So here also we have sodium, oxygen, hydrogen, and sulfur. Right? The number of atoms we already have. Sodium,
1.
oxygen,
5.
1 here, 4 here.
5.
5.
3.
Sulfur.
1.
Done?
Yes.
Those who could not understand why this number of oxygen's number is 5, why hydrogen's number is 3, you may ask. If you won't ask, then you won't understand what is going further. Is it clear to all?
Yes.
Okay, come to products then. Sodium,
2.
oxygen,
5.
4 and 1. 5. Hydrogen,
2.
2. Sulfur,
1.
okay. So, with which atom would you like to start? Sodium?
Yes.
So we have 1 sodium here and 2 sodium there. What would I do? I will write 2 here. This will make number of sodium atoms 2 on left hand side, right? So this becomes 2 and this balances our sodium, right?
Yes.
Then what is unbalanced? We have unbalanced. Oh, this number of oxygen and hydrogen also, because I've placed 2 here. So this changes our number of oxygen and hydrogen. So what is the new number of oxygen atoms? We have 2 oxygen atom here and 4 here. This becomes 6, right? And what is the number of hydrogen now after multiplying this with 2? 4, right? So do you find it easy to make this 2 to 4?
Yes.
What we have to do to make this equal to 4?
Write 2 in front of water.
Yes, we have to write 2 here. We have to make this coefficient 2. How does it change the number of hydrogen? This becomes 2H2 and this becomes equal to 4. And this balances our hydrogen. But does this number change the number of oxygen?
Yes.
What is the number of oxygen atom now?
6.
6. Does this balance our oxygen?
Yes.
Yes. Is the number of sulfur same on both sides?
Yes.
Are you clear? How did we balance this equation?
Yes.
And write it down. Done? Okay, I'll make you write few things about balancing, then we'll do the next example. The more you practice, more expert will you. Write down. Balanced chemical equation. Balanced chemical equation. Heading है. First point is an equation is balanced. An equation is balanced when there is an equal number of atoms of each element on both sides of equation. On both sides of equation. Second point.
Can you repeat again?
Okay, was I fast? Okay, I repeat, an equation is balanced when there is equal number of atoms of each element on both sides of equation. On both sides of equation. This is what we have done. We are trying to make them equal. Both sides of equation. Okay? We are trying to make these atoms equal. This is balancing. Next point. According to law of conservation, of mass, comma, mass can neither be created nor destroyed in a chemical reaction. Which means number of atoms of each element remains the same before and after a chemical reaction. Right? Then write steps to balance the reaction. Steps to balance the reaction. Step one is write the formulae of formulae of reactants and products. Reactants and products. Step 2. Step 2. Check the number of atoms. Check the number of atoms of each element on both sides of equation. On both sides of equation. Step 3. Balance the equation. Balance the equation. And last is step 4. Write the state of the reactants and products. Physical state. Write the physical state of reactants and products, which may take time. You need to learn which one exists in gases or liquid state. But you need to mention the state of the reaction when you write a balanced chemical equation. Right? But first of all, we'll focus on balancing. So we have done few examples of balancing if we are given the formula. What if we are given word equation? From word equation, we need to convert them into formula and then we need to balance. Like in the second half of the assignment, you're given this word equation. Sorry, this sentence is given and you have to write the formulas for this. This says phosphorus burns in presence of chlorine to form phosphorus pentachloride. You have phosphorus. They say that this burns in the presence of chlorine and you get phosphorus pentachloride. Now, first of all, you have to interpret what they are trying to say. You know what is phosphorus? What is symbol for phosphorus? Symbol for phosphorus. And do you know what is its atomicity? In what form does it exist? Like P2, P3, P4, P5, P6, whatever. How do they exist?
P4.
So we'll write this as P4. And what is chlorine? Symbol for chlorine?
Cl2.
Yeah, and it exists as Cl2, diatomic Cl2. Now, what is phosphorus pentachloride? Phosphorus is P. What does penta mean? Penta. Right. So you have 5 chlorine atoms here. Phosphorus pentachloride. So is this a balanced equation? No. So what do? We have written the skeletal equation. Now I'll write what reactants and products do I have here. So what reactants do I have in this equation? P and
Cl.
how many P, how many Cl?
4.
And how many Cl? 2. And here?
1. 5.
And
5.
5. So from where would you like to start? Would you like to balance phosphorus first?
Yes.
So what do we have to do to make this 4?
4.
What do we have to do for that?
Apply 4.
You have to multiply this with this. You have to place 4 here as a coefficient. So does this change the number of chlorine also?
Yes.
So what is the number of chlorine now?
Cl20.
Here is 20. So how do we change chlorine's number on side to make it 20? We have to place 10 here to make it 20. Right? So is this equation balanced now?
Yes.
Are we happy?
Yes.
Okay, so this is done. Write it down. We'll balance next equation then. Shall we start next example?
Yes.
So next statement is burning of natural gas. So what is natural gas? It's methane, CH4, methane. Have you heard of methane? No? Marsh gas, we also call it whenever you smell the gas cylinder, which is a household gas cylinder, that smell is of because of methane. We put methane specially to smell it bad. And burning means heating in the presence of oxygen. And whenever you burn a hydrocarbon, do you understand what is hydrocarbon?
Yes.
Compounds which have carbon and hydrogen.
Yes.
Like alkanes, alkenes,
Alkynes.
all are hydrocarbons. So whenever you are burning a hydrocarbon, you always get carbon dioxide and water. Right? This is a fact. You'll always get carbon dioxide and water and huge amount of energy whenever you're burning a hydrocarbon. Right? So is this equation balanced? No. That means we need to balance it. Again, we'll write the reactants, the side, and products, the sides. Which elements do I have on left hand side?
Carbon. Hydrogen. Oxygen.
And what is the number of carbon here?
1.
Hydrogen.
2.
Carbon, hydrogen, oxygen. How many?
1.
Hydrogen,
2.
oxygen.
3.
Okay. So which is easy to balance? Hydrogen.
Yes.
What do we do to make this hydrogen equal?
Apply coefficient 2 in front of water.
Okay, we have to make this 4. So we have to go this side, and to make it 4, I have to multiply this with 2. This makes your hydrogen 4, but this disturbs the balancing of, number of oxygen atoms here. So what is the new number of oxygen atoms on right hand side?
4.
So now our hydrogen is good, carbon is good, but oxygen is yet to be get balanced. So what do we do to make?
Apply coefficient 2 in front of O2.
You people are very intelligent. Right, so have we balanced it?
Yes.
Okay, write it down. Who are not getting it, kindly tell me. I'm telling you this is very important and this is going to come. So it's better you tell me what you are missing, what you're not able to understand so that we can clarify it in this class only. Okay, moving to the next thing, that is process of
Respiration.
So the reaction which takes place during respiration is that the carbohydrates or the glucose, C6H12O6, that breaks down in the presence of oxygen to give you carbon dioxide and water.
Water and ATP.
And the energy, and we have reactants this side and products this side. And what elements do I have here?
Carbon, hydrogen, oxygen.
And here also.
Carbon, hydrogen, oxygen.
Okay. Number of carbon here.
6.
Hydrogen.
5.
Oxygen.
8.
6 here, 2 here, right? Carbon.
1. 2.
Oxygen.
3.
So which one is easy to balance? These two,
Yes.
right? So what do we do?
Apply 6.
Carbon first. So for balancing carbon, what we have to do?
Apply 6 in front of carbon dioxide.
Multiply this with 6 to make them equal, right? So this becomes 6 here, but this changes the number of oxygen atom on right hand side. What is the new number of oxygen atom?
13.
How many? 13. Right? And for balancing hydrogen, what do we do?
Apply 6 in front of water. Front of water.
We make it 12, so we multiply it with 6 here. Now this becomes 12. But does this change number of oxygen?
Yes.
What is the new number of oxygen? Anji?
18.
कुछ गड़बड़ तो नहीं किया? Fine. So to balance oxygen, to make it 18 this side, you have to see that you have 6 here. You're not going to change it, otherwise these two are getting disturbed. So what should you do here? What number should be placed here?
9.
But I'm getting, मुझे कुछ गड़बड़ लग रहा है इसमें.
9 2s are 18.
But you have to make it total 18. You already have 6 oxygens here, and you need how many more? How many more?
6 आएगा.
You have to place 6 here so that you get total 12 oxygen here and 6 oxygen you already have in glucose, right? So you place 6 here and this makes
18.
18 and the equation is balanced. So you have to multiply carefully by considering all the reactants, by considering the change, cut down the previous number which you have, the number which you have about the atoms, and write down the new number after that, so that you're very clear. Okay?
Yes.
Okay, write it down then. Okay. Shall we proceed to next?
Yes.
So next word equation is solid calcium carbonate. Calcium carbonate is heated and decomposed to solid calcium oxide, which is CaO. Do you know how do we make these formulas? Do you know the names of these formulas or not?
Yes.
Yes. Those who don't know, please tell me. How do we make? What is carbon oxide? All of you know the formulas?
Yes.
Okay. This gives you calcium oxide and carbon dioxide. And we have calcium oxide.
Carbon oxygen. Calcium carbon oxygen.
What is the number of calcium atoms? Carbon
1.
Oxygen, calcium,
1.
carbon,
1.
oxygen.
B.
Do we need to balance this?
No.
It's already balanced.
Balance.
Right. Okay. Then is this fifth one. It says gaseous butane, C4H10 is butane, reacts with the diatomic oxygen. This is also a combustion reaction, and you're getting carbon dioxide and water here. So we write the number of reactants and products. Carbon, hydrogen, oxygen.
Carbon, hydrogen.
Anji, what is the number of carbon here?
4.
Hydrogen,
10.
oxygen,
2.
carbon,
1.
hydrogen,
2.
oxygen.
3.
Okay, which is easy to balance. Shall we proceed with?
Carbon.
Okay, what do we need to balance carbon?
Apply 4 as coefficient.
Yes, you need to make this
4.
carbon number 4. So we multiply this CO2 with 4, and this makes the number of carbon 4. But this changes the number of oxygen here.
Okay.
Common coefficients to both the elements.
9.
Number of oxygen is
9.
8 here and 1 this one. Don't forget the other one, right? Then, shall we balance hydrogen now?
Yes.
You have 10 here, 2 here. So what do we do?
5. 5.
Try this water molecule with 5. But again, this balancing your hydrogen, but it is changing the number of oxygen here. How many atoms? New number of oxygen atoms now.
4.
And 4, 2,
30.
8. 8 and 5 is?
30.
Now, how do we make this 13? Tell me. Can we make this O2 13?
No.
So, will it remain unbalanced? No. So, what do we do? See, oxygen cannot exist in monatomic form. It cannot exist as O. It will always exist as O2. So, what do? If we have an odd number, we put that number here and divide this by 2. This becomes 13 by 2 into 2 and equal to 13. And this will, especially these equations are very common, and you'll study these equations in higher classes also. And I told you, whenever you burn a hydrocarbon or whenever a hydrocarbon undergoes combustion, it always gives you carbon dioxide and water. And mostly you'll get this odd number. You'll get 7, you'll get 9, you'll get 13, you'll get 15, you'll get 17. You'll get these numbers in different hydrocarbons. So the best way to balance them is calculate the number, or if it is odd number of oxygen atoms here, then write the same odd number this side and divide that with 2. Right? This will give you the odd number of oxygen atoms on left hand side. Fine?
Yes.
So this makes your number of oxygen atoms 13 on left hand side also. By placing this 13 by 2 on left hand side before oxygen atom. Is that clear?
Yes.
Okay. Okay, wait for you, or shall we start the next example? Are you still doing, beta?
No.
Okay, then we'll start with the next example. Next is aqueous solutions of magnesium chloride and sodium hydroxide react to produce magnesium hydroxide. This is, let me write the word equation. This is magnesium chloride plus sodium
Hydroxide.
hydroxide And this is giving you
magnesium hydroxide and sodium chloride.
hydroxide and sodium chloride. Right. So what is the formula for magnesium chloride? MgCl2, because magnesium carries 2 positive charge and chlorine carries -1 charge. This crosses and gives you MgCl2. And what is the formula for sodium hydroxide?
OH.
So Na is 1 positive and OH is 1 negative. So NaOH. And magnesium hydroxide,
MgOH2.
we have Mg2 positive and hydroxide ion is OH negative. Because hydroxide ion is made up of 2 different atoms, we put this in a bracket. Whenever we have more than one atom carrying a charge, that is a, we call it complex ion, we put it in the bracket. So this is the +2, this is -1. We cross this and we get MgOH twice.
NaCl.
And sodium chloride is
NaCl.
I hope I'm not doing it very at fast pace. Are you able to understand what I'm telling you?
Yes.
So,
Yes.
is it okay?
Yes.
Okay, fine. Then let's write the number of reactants and products then.
Magnesium, chlorine, sodium, oxygen, hydrogen.
ज़्यादा हो गया. Let me clear it and write it a bit smaller.
Magnesium, chlorine,
Sodium,
oxygen, hydrogen.
okay. Number,
1,
chlorine,
2,
sodium,
1,
magnesium,
1,
chlorine,
1,
sodium,
1,
oxygen,
2,
hydrogen.
2.
So, from where should we proceed? What is easier to do? I think it's easier to balance chlorine because we need to put a coefficient here.
Yes.
You should start with the easier one, right?
Yes.
So, let us balance the chlorine. This makes it
2.
NaCl, but this changes the number of sodium atoms here also. This makes it 2. So what we have to do to balance this sodium now?
OH.
Multiply this with 2, right? So this makes the number of sodium 2, but this changes the number of oxygen and hydrogen here. So what is the new number of oxygen on left hand side?
2.
And new number of hydrogen on left hand side?
Balanced.
Does this balance our equation?
Yes.
So whenever you write the atoms and then number on reactant and product side, choose that thing which you think is easier. Then start with that, and that will change number of other atoms. If it is a compound and you're adding a coefficient in front of it, it will definitely change the number of atoms of for other things. Then you start with the rest of the things, right? So choose the easier one, whatever I would like to say. Okay. Is this done, beta?
Yes.
Shall we proceed with the next example then?
Yes.
Okay. This was 6th one. Then it's 7th. Water vapor reacts with sodium metal. Sodium metal is sodium. Water vapor is metal is solid in state. Water vapor means this is gaseous in state. And this produces sodium hydroxide, which is
NaOH.
and you have hydrogen gas. What is hydrogen gas?
H2.
Fine. We have sodium and
hydrogen, oxygen.
okay. What is the number of sodium on left hand
1,
and right hand side?
1,
Hydrogen here. And there,
3,
oxygen
1,
this side
1.
1. Okay. So we need to change the number of hydrogen, but we cannot, make this this side 3. So what do we do? If I multiply this with
2.
2, then this becomes 4, no? Then we have to multiply this also with 2.
Yes, it will change oxygen.
But hydrogen is also there. If I multiply this with 2, then this is no. Let's try with this. If we multiply this with 2, this gives you 4 hydrogen atoms and 1 5. This won't help now. This is again odd. So let's multiply this with 2. What will this do? This will make hydrogen atoms 4 here. If I make it 4 here, okay, and then to make it even that side, I have to multiply with 2 here.
Yes.
Does this balance my hydrogen now? I've made it 4 here and then I get 4 hydrogen atoms total on right hand side. See, this is hit and trial method. You have to see what is more comfortable. So this is making your hydrogen atoms 4 here. But does this change the number of sodium atoms?
Yes.
And oxygen also.
Yes.
Sodium is 2 here now. And oxygen is also 2. And
Yeah.
the number of sodium, you have to multiply this with 2 here. And you have 2 number of oxygen atoms on left hand side.
Balance.
Sit down. Take your time to understand what we have done.
Next question, same. Connected. What is balance from a reaction with calcium hydroxide and nitric The second part. Mami asked me yes.
Okay. Coming to the next one, this says water reacts with oxygen. Water is H2O.
And this has second part also.
Okay, seventh, we have missed the seventh.
Yes, it has also second part. What is balance form of reaction between calcium hydroxide and nitric acid?
Nitric acid. Okay. So this is calcium hydroxide. Calcium hydroxide and nitric acid. Nitric acid. अच्छा आपको कौन? Okay, what is the formula for calcium hydroxide?
CaOH2.
CaOH twice.
HNO3.
And nitric acid is?
HNO3.
So this is HNO3. So what products are we going to get?
CaNO3, OH2.
We are going to get calcium nitrate
Yes.
and water. Right?
Yes. Yes.
Now try to do it yourself, by yourself, please. And let me know the answer. Write the number of reactants here, this side and this side. Try to balance it. Let me see how much can you do. And let me know the balanced equation.
Oxygen 7 आएगा.
7 आएगा?
Yes.
Which side?
Side product side.
This side. Done? Not done?
Yes.
No. Okay. Done, beta? Yes. Okay, tell me. What is the final balanced equation? Tell me what is the change in coefficients here? How many calcium hydroxide?
2HNO3.
Hanji?
2HNO3.
I was asking you what is the number here. This is 2HNO3. And what is the coefficient here? And what is the coefficient here? Okay. हो गया आपसे? हो रहा है अभी?
Yes.
Try one more equation then. To the next question, this is eighth one. If water reacts with oxygen to give hydrogen peroxide. What is formula of hydrogen peroxide? H2O2 is hydrogen peroxide. Right?
Yes.
Balance it and let me know the coefficients after balancing.
I'm done.
Done.
Yes.
Give me the coefficients.
Two.
Before water, 2H2O. Before oxygen,
1,
before hydrogen.
2.
Okay, this makes number of hydrogen atoms. For this side, oxygen atoms. For this side, and this is done. Okay. Any questions from this?
No.
No? Would you like to do one more question? Yes, then come to sixth unbalanced equation first part. Sixth equation, CH4. This is methane. I think we have done this in word equation. CH, but this is already balanced. This is coefficients are already given, so this is done. CH4 plus 2O2 gives CO2 plus water. Next one also we have done in the respiration process. Then come to eighth one. Eighth equation, which is H2S plus SO2 gives S plus H2O. This is reactant, this is product. Write down number of hydrogen, sulfur and oxygen here, and hydrogen, sulfur and oxygen here. Balance it and let me know. Done?
Yes.
Tell me the coefficients. What should I fix before H2S?
2.
2. Before SO2?
1.
1. Is it?
3.
3 sulfur and how many water molecules?
2.
Okay, let me check. You say that you have 4 hydrogen atoms here and you have 4 hydrogen atoms. Okay. Sulfur, you have 3 sulfur atoms here and 3 sulfur atoms this side. Right. And you have O2. 2 oxygen atoms here and 2 oxygen atoms here. Is this balanced?
Yes.
Okay, then complete your assignment for the next class. And okay, ma'am will have a word with you. So yes, good morning students.
Good morning, ma'am.
So बच्चों मुझे पूछना है आपका जो है केमिस्ट्री का जो चैप्टर अभी चल रहा है क्लास में हो चुका है? Is it done?
No.
It's going on.
No. We have started with physics.
We have started with physics. Okay. And what about maths? Real chapter is done. Real number chapter.
Yes.
It's completed.
Yes.
So that's enough. So okay, students. Bye.
Bye, ma'am.